Lentils are one of those humble, unglamorous foods that don't generate much excitement in wellness circles, but when you examine their nutritional profile and metabolic effects, they offer some genuinely valuable support for brain health and NAD plus metabolism. Let's explore what makes lentils relevant to this conversation while acknowledging some practical challenges and individual variations in how people respond to legume consumption. The connection to ND plus metabolism operates through several pathways. Lentils provide plant-based protein with a good amino acid profile, including tryptophan, which, as we discussed earlier, can be converted to NAD plus through the kynurenine pathway. They also contain B vitamins, particularly folate, thiamine, and small amounts of niacin, which support ND plus synthesis and the broader metabolic context in which ND plus functions. What makes lentils particularly interesting is their effect on blood sugar regulation. Lentils have a low glycemic index and provide both protein and fiber, which slows glucose absorption and promotes stable blood sugar levels. This matters enormously for brain health because blood sugar instability is associated with increased oxidative stress and inflammation, both of which accelerate NAD plus consumption. Stable blood sugar also supports steady energy delivery to the brain, which is critical since the brain uses about 20% of the body's energy despite being only 2% of body weight. The fiber content in lentils supports gut health, and emerging research suggests that gut microbiome composition affects brain health through multiple mechanisms, including inflammation control, neurotransmitter production, and even direct effects on ND plus metabolism. Some gut bacteria can synthesize ND plus precursors, and a healthier gut microbiome may contribute to better systemic NAD plus status. Lentils are also rich in polyphenol and other antioxidant compounds that reduce oxidative stress. The iron content supports oxygen transport and mitochondrial function, though plant-based iron is less bioavailable than heme iron from animal sources. The magnesium in lentils supports hundreds of enzymatic reactions, including those involved in energy metabolism. Now let's discuss some significant challenges with lentils. First, digestive tolerance varies dramatically between individuals. Lentils contain oligosaccharides that humans cannot fully digest, leading to gas, bloating, and discomfort for many people. For someone with IBS, inflammatory bowel disease, or other digestive sensitivities, lentils can cause substantial distress. If eating a food makes you uncomfortable and stressed, the stress response could potentially negate some metabolic benefits. Soaking lentils before cooking and discarding the soaking water can reduce these problematic compounds somewhat, but many people don't know this or don't take the time. Most people just cook lentils directly, which maximizes the digestive issues. Even properly prepared lentils cause problems for some individuals. The anti-nutrient content is another consideration. Lentils contain phytic acid, which binds to minerals like iron, zinc, and magnesium, reducing their bioavailability. They also contain lectins, which are proteins that can cause digestive irritation in some people and may interfere with nutrient absorption. Cooking destroys most lectins, but not everyone tolerates even cooked lentils well. For people with gout or elevated uric acid levels, lentils are moderately high in purines and could potentially trigger gout attacks or worsen existing conditions. This is less of a concern than with organ meats, but it's still relevant for susceptible individuals. Cultural and culinary barriers are real. In many Western food cultures, lentils simply aren't part of traditional cuisine, and people don't know how to prepare them or find them unappetizing. Telling someone to eat lentils regularly when they've never cooked with them and don't like the taste or texture isn't particularly helpful advice. Nutritional recommendations need to be culturally sensitive and practical. The protein quality in lentils, while decent, is incomplete. They're low in methionine, though this can be complemented by combining with grains or other foods. For someone relying primarily on plant-based protein, variety is important to ensure adequate intake of all essential amino acids. There's also significant variability in lentil quality and nutrient content based on growing conditions, storage time, and preparation method. Old lentils that have been stored for years have reduced nutrient content compared to freshly harvested lentils. Canned lentils are convenient, but often contain added sodium and may have reduced nutrient content from processing. The environmental profile of lentils is generally positive. They're nitrogen-fixing legumes that actually improve soil health, require less water than many crops, and have a lower carbon footprint than animal proteins. From a sustainability perspective, increasing lentil consumption while reducing meat consumption would be beneficial. The realistic recommendation would be 1/2 to 1 cup of cooked lentils, 3 to 4 times per week, for someone who tolerates them well. They should be properly prepared, sorted, rinsed, and ideally soaked before cooking. For maximum digestibility, cook them thoroughly until soft and consider adding digestive spices like cumin, fennel, or ginger. In conclusion, lentils offer solid support for brain health through stable blood sugar regulation, NAD plus precursor provision through B vitamins and amino acids, and gut health support through fiber. They're nutritionally dense, affordable, and environmentally friendly. However, digestive tolerance varies widely, and preparation method matters significantly for both digestibility and nutrient availability.